Hello everyone, welcome to this session. Today in this session we are going to discuss regarding factors which are influencing the hydrographs, and also we are going to see what is unit hydrograph. Friend, in last session we have seen regarding the hydrographs, how the hydrograph is prepared, what is its nature, what is the hydrograph, what is the correlation between these two. So all these things are there. Also we have seen all the terminologies. So how the various factors are there which is going to affect the hydrograph, and also how a unit hydrograph is prepared and what is its application, that we are going to study today. Now the factors which are going to influence the storm hydrographs, those are area, shape, slope, type of rocks you can say, soil, land use, drainage density, precipitation, or temperature, associated temperature, various tidal conditions. These are the various factors which are strongly influencing the storm hydrographs. So before that also let's revise some part regarding that we have seen regarding the hydrograph. So before going to the various factors which are going to affect the this storm hydrographs, those are especially the parts that we have seen regarding the hydrograph, which where the duration is plotted on the x-axis and the discharge on the y-axis. So the rising limb, recession limb, then the rainfall intensity. So all these terms are which are based or necessary to understand. So earlier that we have seen regarding this the rising limb. What is a rising limb? Then what is recession limb is there? What is the basin lag time? What is a peak flow, or which is called as a crest? This is a hydrograph, right? So all these terms, remember that those are required. So how the base flow is calculated, how the through flow is calculated, how the overland flow is calculated. That we have seen in the earlier sessions. So, um, so all these factors of a storm hydrographs, how though these are going to affect with the various characteristics or various points, those we are going to study. Now, number one is the area. Large basins receive more precipitation than small, therefore have larger runoff. It is direct, remember. Okay. So if the large area is there, in case that will be the discharge will be more. If the smaller area will be the discharge will be less. Larger size means longer lag time, as the water has a longer distance to travel to reach the trunk river or the major stream. Okay. So area is the major factor which is influencing the hydrograph. Next one is the shape. Elongated basins will produce a lower peak flow and longer lag time than a circular one of the same time. So this is very important, that how the shape is going to affect elongated basin shape, that will be producing a lower peak flow. Okay, so you can see depending upon the this is a longer catchment is there. You can see resulting hydrograph is like this. Then the catchment, okay, medium catchment, the resulting hydrograph is like this. Okay, the catchment shape, depending upon the catchment shape, you can see. Okay, how the hydrograph is changing. The shape is matter regarding the hydrographs. Then slopes, the in the terrain, what kind of slopes are present, that is also going to affect uh, hydrograph. Channel flow can be faster down a steep slope, therefore steeper rising limb and shorter lag time. So this is very important. Uh, if the steep slopes are there, depending upon the those the this hydrograph depends. You can see here for the steep slope how the hydrograph is there, for a gentle slope how the hydrograph is there. Okay, So the slope also going to affect. Okay, rock type permeable rocks means rapid infiltration and little overland flow, therefore shallow rising limb. Okay, if the strata is porous, in that case infiltration will be more and there will be less overland flow and the rising will be very shallow. So what type of rocks are present in the that terrain, that is also going to affect the hydrograph. Type of soil. Infiltration is generally greater on thick soil, although less porous soils, for example, clay acts as an impermeable layer. Okay, the most infiltration occurs the longer the lag time and the shallower the rising limb. So on soil type again this type of, if impermeable soil is there, you can say a steep rising limb will be there. But in the permeable soil, you can say shallow rising limb will be there. So soil type also going to affect the nature of the hydrograph. Land use. In urbanization, concrete and this tarmac form impermeable surfaces, creating a steep rising limb and shortening the time lag. Afforestation intercepts the precipitation, creating a shallow rising limb and lengthening the time lag. So, because of this concrete and the used material there, so this is also because of the urbanization, you can say it is going to affect, right? So also, you can see here the one example is shown because of the vegetation. If the vegetation is there, what kind of hydrograph present? If the no vegetation is there, hydrograph will be like this. Okay, the same thing is shown here. Drainage density. Now, higher the density will allow rapid overland flow. Okay, the two cases have been shown here where higher drainage density is there. So you can observe the type of hydrograph which is obtained, and if the low drainage density is there, so you can see how the slopes are there in the hydrograph. So drainage density of that area, that is going to affect the hydrograph. Precipitation and temperature. Short, intense rainstorms can produce rapid overland flow and steep rising limb. If there have been extreme temperatures, the ground can be hard, either baked or frozen, causing rapid surface runoff. Snow on the ground can act as a store, producing a long lag time and shallow rising limb. So once a thaw sets in the rising limb will be become steep. So this precipitation, what kind of precipitation is there in that area? So that based on that, the nature of the hydrograph depends, and temperature also going to affect the nature of the hydrograph. Then in tidal conditions, higher spring tides can block the normal exit for the water, therefore extending the length of the uh, time the river basin takes to the return to the base flow. So tidal conditions that are going to affect, because this directly depend upon how the main stream that is going to accept the water from the catchment area. So tidal conditions are very important in this. Then let us have the glance on the hydrograph before proceeding to the unit hydrograph. So let us have the repetition on that. So hydrograph, what is hydrograph? It is a graph showing the rate of flow discharge versus the time past a specific point in the river or any other channel or conduit carrying the flow. It can also called as a graph showing the volume of water reaching a particular outfall. Okay, hydrographs are commonly used in the design of sewerage, more specifically the design of surface water sewerage system and combined sewers. Now that components that we have seen, will just recall this. to understand the further part. Now the parts that we have seen regarding the rising limb of a hydrograph, also known as a concentration curve, reflects a prolonged increase in discharge from a catchment area, typically in response to a rainfall event. Recession or falling limb, that we have also seen. The recession limb extends from the peak flow rate onward. The end of storm flow, or you can say quick flow, direct runoff, and the return of to the ground flow, derived flow, or which is called as the base flow, is often taken as the point of inflection of the rising limb. The recession limb represents the withdrawal of water from the storage built up in the basin during the earlier phases of the hydrograph. Then also we have seen the four other terminologies: the peak discharge, the highest point on the hydrograph when the rate of discharge is greatest. It is called as the peak discharge. Lag time, the time interval from the center of mass of rainfall excess to the peak of the resulting hydrograph. So that we have also seen. Time to peak, the time interval from the start of the resulting hydrograph, it is called the time to peak. And discharge, the rate of flow volume per unit time passing a specific location of in a river or other channel, it is called the discharge which is associated. So this also we have seen earlier that this is the rising limb. You can see the peak rainfall is there. Okay, from the peak rainfall to the peak discharge, this time gap, it is called as a lag time. Okay, this is the rising limb, this is the peak discharge or the crest wave, this is a falling limb or recession limb is there. So these two inflection points. Okay, so we are joining this as there. This is a normal flow, or this is the base flow here, and this is the storm runoff. All these factors that we have studied, right? So what is unit hydrograph now? Hydrograph usually consists of a fairly regular lower portion that changes slowly throughout the year, and a rapidly fluctuating component that represents the immediate response to rainfall. The lower, slowly changing portion is termed as a base flow. The rapidly fluctuating component is called as a direct runoff. So you can see this figure here, which is plotted again a time interval and a discharge, right? So for a typically for a unit time interval, you can say the hydrograph is obtained. So the amount of runoff resulting from a one unit, 1 centimeter, 1 mm, 1 feet, etc., of rainfall excess, it is essentially a tool for determining the direct runoff response to rainfall. Once you know the watershed's response to one storm, you can predict what is the response for the another will look like. So unit hydrograph, remember, it is obtained for the one unit. Okay, depending upon the what type of unit you have used in the preparation of the hydrograph. So you can see here in this case. So for a typical unit it is obtained, or a single unit it is obtained. So basic assumption when you are preparing the unit hydrograph, so what is expected? The effective rainfall is uniformly distributed within its duration. That is the basic assumption. The effective rainfall is uniformly distributed over the whole drainage basin. So this is also an assumption. Remember, the base duration of direct runoff hydrograph due to an effective rainfall of a unit duration is constant. Okay. Then the uh, ordinates of the this DRH are directly proportional to the total amount of DR of every hydrograph. For a given basin, the runoff hydrograph due to a given period of rainfall reflects all the combined physical characteristics of basin time variant. This is a time variant. So these are the various assumptions that is considered in the unit hydrograph. So as we understood that this unit hydrograph is a direct runoff hydrograph resulting from one unit, that may be 1 inch or 1 centimeter of a constant intensity uniform rainfall occurring over the entire watershed. The concept of unit hydrograph is based on linear systems theory and follow the principle of superposition and the proportionality. So in the coming lectures we are going to see the regarding the all these various types of or various factors which are associated with the unit hydrograph. But here is very important to understand that in case that when you are plotting this, the this ordinates of the this direct runoff hydrograph are directly proportional to the total amount of the direct runoff of each hydrograph. So while preparing this hydrograph, unit hydrograph, this is a very important thing that we have to remember. So today we have seen the various factors which are influencing the a storm hydrograph and also the concept unit hydrograph. So in the coming sessions also we are going to study how the unit hydrograph is prepared and how the derivation is there which is associated with the unit hydrograph. So friends, thank you very much for joining the session.